Hi. So as has become a custom over the past years at DappCon, I will be talking about Gnosis Chain and, well, hardforks and updates, basically. So I always like to start a bit about talking about what Gnosis Chain actually is. Some of you still might not know. Actually, by show of hands, who knows about Gnosis Chain here? OK, that's a decent amount of people. But still, quick reminder. So Gnosis Chain basically is the same as Ethereum. So it has a beacon chain. It has the same clients. It goes through the same hard forks. And it's also all about decentralization. It also has a few differences, though. For example, it was based on proof of authority before the merge. It uses GNO as the staking token, which is an ERC20 token. And it has faster block times and finality. It also has a few less blobs per block. So we have for execution layer clients, which are Nethermind, Aragon, Geth, and Wrath. So Nethermind basically, over the past year, did a lot of bug fixes and performance improvements. But they also developed this R1 file support, which basically means that you can now export and import data, so bodies, receipts, headers, everything from your node, and then re-import it back. That's important because soon, pre-merges we will actually get dropped entirely from nodes and thus the peer-to-peer network. So you won't be able to sync a node from scratch, basically, without importing ERA files. Aragon deployed its version 3. Which comes with a built-in consensus layer automatically, so you only have to run Aragon by itself without Lighthouse or Teco or whatever, which is great for RPC providers, for example. Of course, you cannot validate just with that. And it also has static expiry, so basically the same as Nethermind. Geth, I announced actually last year here at DappCon, is now stable. It is basically, it has feature parity with upstream Geth. And it also supports historical data for Gnosis Chain, so the pre-merge stuff. And if you want more information about Geth, I think Guillaume is actually giving a talk at Studio A tomorrow at 2:40, if I'm not mistaken. And then today, similarly as last year, I can announce that we also have Wrath now, which is a new client. It doesn't support pre-merge headers or data at all. It doesn't support snapsync, so there are a few caveats. But it is actually already a testing, so you can run it on your validator if you want to. Quick word about client diversity. It's extremely important because if a client has an issue, basically the whole network could go down. And right now on Gnosis Chain, almost or more than 80% actually of the validators are Nethermind, so that's not great if in case Nethermind has an issue. So please, if you are validating on Gnosis Chain and you're running Nethermind, consider running something else. So you have 3 options now. You have, as mentioned, Geth, Wrath, and Aragon. We did a lot of work to, get those clients. Please use them and save the network by having client diversity. So this is the hard fork timeline that we did in the past. So we started hard forking, we did the merge basically 1 year after Ethereum. And since then, we've become basically faster and faster until DappCon, where we actually hard forked 2 days before Ethereum, and now Pectra, which we did 1 week before Ethereum. And then the next hard fork is supposed to be, is going to be Fusaka, potentially end of this year or at the beginning of the next one. So what is Pectra? This is a full list of EIPs. I'm not going to go through all of them because they are not really relevant, I would say, for users and validators. But for validators specifically, I want to talk about 2. So there's EIP 7002, which allows basically owners of validators to withdraw and exit validators directly. So in the past, there were 2 keys, so the withdrawal credentials, which own the funds on chain, and then an active key that is run by validators. So imagine someone here in the audience had like 100 GNO, for example, but didn't want or didn't know how to validate with them themselves. They could delegate it to me, for example. I would run the nodes for you. But then I could hold your funds hostage, because I'm the only one with the keys that can actually release that money. I would not be able to steal it or do anything with it, but I could basically just hold it hostage, right? Which is very bad. With this EIP, you can actually now, as the owner of the funds, withdraw and exit the validators whenever you want, so you are not dependent on your node operator anymore. So that's a bit better for validators. Then EIP 7251, which I would say is the biggest one for Pectra. It aims to increase the maximum effective balance. What does this mean? Basically, until Pectra, if you had 100 GNO, for example, you would have to run 100 different validators, different keys, so maintain the keys, and then attest and sign with all of them, which is, consumes a lot of hardware in terms of memory, networking, CPU, everything, basically. So it's not great, and it's also difficult to manage all those keys and to keep them safe. Then there's an additional issue that if you had, for example, 1.99 GNO, you would only be able to create one single validator, and the 0.99 that remains are, not usable. So that's capital inefficient. Of course, for Gnosis Chain, it's not that important because 1 GNO, all things considered, is not worth that much, which is by design for Gnosis Chain. But for Ethereum, if you had, let's say, 40 ETH, you would have to wait until you had 64 to actually be able to spin up a second validator, which is a lot of money. So this EIP actually fixes both of these issues. You can now consolidate multiple validators into one. So imagine you have 100 keys. You can now just consolidate them into 2 validators with 50 GNO each. So it's much more efficient, much easier to handle. And as a general, you should do it. Basically, it's way more efficient for the network, even on the peer-to-peer network, so it's better for everyone if you consolidate. And you can also now stake any amount between 1 and 64 GNO on one single validator, and you will actually get compounding interest or yield on any of those amounts. So if you have 1.99 GNO, you can put those on one single validator, and you will get compounding rewards. So how does that work in practice? Basically, you have 2 options. You can keep the old behavior, so stay as it was before. In this case, you don't have compounding, you don't have consolidations, you run the same number of keys. Basically nothing changes. You still get your partial rewards once every few days on Gnosis and a couple of weeks, I think, on Ethereum. Or you can upgrade to become compounding, so the new post-Pectra way of doing the things, basically. And you get all the, benefits I just talked about. And again, this is the recommended choice because it's good not only for you, but also for the entire network. So how can you do this? For new validators, you can use the ETH Staker deposit CLI, which I'm actually also happy to announce now that works for Gnosis Chain. So we have the same tools now for Ethereum. It just makes things easier. You don't have to run something different for Gnosis Chain and for Ethereum. So you just use the compounding flag. Or if you have current validators already and you want to consolidate them, technically this would be done with smart contracts. But honestly, just use the easy way. We have a tool available for you here on consolidate.gnosischain.com. It does have a few caveats. Namely, it only works if your withdrawal credentials are a safe wallet or with MetaMask, because they are the only one to implement 7702 right now. I'm going to talk about that a bit later. But it also works for Ethereum, Sepolia, and Chiado, of course. So you can use this for all your validating needs. This is what it would look like. So on the interface, you would see, for example, here I have 505 validators that I want to consolidate. And I'm choosing to end up with validators that have 32 GNO on each. And this will result in having 16 validators in the end. So I will have way less keys to manage, way less peer-to-peer traffic, way less signing and attesting, so it's way more efficient. And on the second screen, you will see that all those transactions, normally I would have to do 505, are actually batched in only 3 transactions. So you only have to sign 3 transactions. Imagine you had to sign those 505 transactions on your ledger, for example. That would take a lot of time. With EIP 7702, that is way easier. And actually talking about 7702, what it does basically is to allow you to set an EOA on, to set account codes on an EOA. So basically each address now becomes a smart wallet, or you can make a smart wallet out of it. So the pros, of course, are that you can execute arbitrary codes on your EOA. For example, you can do batch requests. So we all know this flow about doing approve plus transfer for tokens into different transactions. That's not great. Now you can do this in one single transaction. Or, for example, you could send many different tokens to many different users in one single transaction. So that's great for user experience, but it also has a few pros. Well, the support is not great yet. It's potentially dangerous, and it's kind of gate kept by wallets, but that's kind of by design for your own security, because this actually, well, is dangerous in the sense that it makes it possible to lose all your assets, tokens, native tokens, everything, NFTs, in one single transaction. So you have to be very careful about what you do with this. So we just talked about Pectra, and I want to talk a bit about how Hardfolks actually work, how we execute them. And of course, there's a lot of preparation. So we have a lot of automated tools for this, for testing. For example, Hive tests, ESTs, or Ethereum/tests. I mean, a lot of repositories to do automatic testing. And then we have DevNets, which are spun up by the DevOps or CodeDev teams. For example, for Ethereum, it's mainly Eatpanda Ops. And those generally start on the hard fork before, so the one that is not being developed, for example, DappCon in this case. And then, for example, one day later, you do the hard fork transition to Pectra, so you can test that everything still works. And afterwards, you can, of course, test that all the features are still, well, functioning. So usually there's between 5 and 10 of those DevNets. For Fusaka, for example, the first 2 already were deployed. And, well, this allows teams to make sure that everything works together with other clients, and, yeah. And the feature sets are always, well, usually different, because during the development period, of course, features get added, new IPs get, well, added to the hard fork or get changed. So DevNets usually have different configs and are used during development. And then we have testnets. Well, like networks usually have a testnet at least. They are usually free to use, although it's a bit complicated on Ethereum from time to time. But they are used for Dapp developers as well, so they can test on a chain without having to pay for it. They can do interoperability with it because they can, for example, interact with Aave or Uniswap or Gnosis Pay or whatever the case may be. But it's also useful for the hard fork because it's the last step basically before hard forking to mainnet. And then we can make sure that everything still works because usually they are fairly close to, well, mainnet. So how did this go for Pectra? It didn't go very well. The first 2 networks to hard fork were Sepolia and Holeski. Both failed in different ways. Sepolia was recovered very quickly, so that's all good, but Holeski took way longer, weeks actually. And yeah, after that, Shadow, which is an Ocean testnet, actually hard forked, and it was the first one to successfully hard fork from the get-go. Although, to be fair, it would have had the same issue as Sepolia, so we kind of got saved by DF in this case. And then a third network that didn't exist before, Hoodie, was created, well, just so that we could make sure, basically, that the hard fork would go through on an actual testnet before going to mainnet. And this also delayed Ethereum mainnet because rollup teams needed to have 30 days between the last testnet and mainnet to make sure that they have enough time to test everything. So yeah, this was basically the hard fork timeline. So Holeski and Sepolia forked first, and then Shadow one day after Sepolia. Then Hoodie was created out of nothing, so it took a bit longer, and 20 days after Shadow, Hoodie hard forked. And then we have Gnosis Chain, so mainnet on April 30, and Ethereum mainnet on May 7. So what did this mean for developers? It was not great because a lot of developers relied on Holeski to well, test their applications and interoperability. But the network was down, so developers had to basically deploy to another network, so spin up the entire infrastructure again, which took a lot of time. And here I want to be a bit, well, it's going to be biased, of course, but I would recommend to deploy to Gnosis Chain next time, because it's a production-grade network that is very cheap to use and that does hard fork before Ethereum. So you actually get, for example, here for Pectra, 1 week of testing on a post-fork network. And you can basically, well, it is very cheap. As a matter of fact, if you have an interesting project to deploy, just hit me up and we will pay for gas. So what did we learn from this? Communication is always difficult. For example, Hoodie was just, well, messed up because client teams basically didn't use the same configurations. And this really shouldn't happen anymore at this stage on a production network. So yeah, testing is, of course, always extremely important. And then there's some EIPs that don't necessarily generalize too well. For example, the issue that Sepolia had is that one EIP basically assumed that there was only one event in the deposit contracts, which was the case for Ethereum mainnet, but wasn't for Sepolia, and also isn't for Gnosis Chain and Shadow. Yeah, so it's basically a sad error in the sense that filtering events is trivial and actually extremely cheap in terms of computation, so it was worth it to do it from the get-go. And that's also the fix that was done later on to fix Sepolia and our networks as well. So yeah, just filtering the event could have saved a lot of time in this case. So we have to be very careful about, yeah, generalizing EIPs, basically, and us for Gnosis to make sure that EIPs we integrate actually fit, because our network diverges from Ethereum a bit. All right, so moving on to Fusaka, which is the next fork. This is the list of EIPs, but I'm actually not going to talk about any of them because I think they are not very relevant for users and validators. It's basically all about scaling. But if you want to learn more about scaling the layer 1, there's a talk from Tony Washletter from DF tomorrow, Studio A at 2:15, if I'm not mistaken. So yeah, that's it for me. Thanks for listening. And if you have any questions, please go ahead.
Thank you, Philippe. Yes, we have a moment for questions here. If there's anyone in the crowd that has a question for Philippe.